Hello guys, myself Rapak Manoj Kumar. I am pursuing my PhD in Amruta Vishwavidyapeetham. Today I will discuss the introduction of power semiconductor drives. So we will move on to the first unit. This is the unit number 1, control of DC motors by single phase converters and 3-phase converters. This is the first unit. Your first unit is of 2 parts. Part 1 consists of single phase converters and second part is 3-phase converters. So in these converters also, if you consider single phase converters, or thyristor control drives, it is of 2 types: fully controlled converters as well as semi-controlled converters. So in these also you will study 2 types of motors: fully controlled single phase converter with series motor, as well as separately excited motor. In the semi-controlled also you will study about the series excited motor, semi-controlled, as well as in the semi-controlled with separately excited motor. This is of your first part. So here I will give a brief discussion. So thyristor control drives, here single phase semi-controlled converters and fully controlled converters, which is connected to separately excited as well as DC series motor. We will study their voltage and current waveforms as well as speed torque characteristics of both motors, separately excited motor and series motor, for semi and full. We will discuss in the first part. In the second part, in the 3-phase converters. In the 3-phase converters also we will study 2 types: semi-controlled as well as fully controlled. In this also you will study the separately excited as well as series. So semi-controlled also it is of 2. You will take 2 for separately excited as well as series excited motors. You will study 2 types. Next, there is speed torque expressions also. You will study their speed torque expressions and their problems. This is of your first unit. So first we will move on to what is meant by electrical drive. So drive is a system which is employed for the movement control. A system which is employed for motion control. So motion control or controlling movement of the system is known as drive. So here this motion control is required for a large number of industrial and domestical applications. So if you see, we will use in transportation systems, rolling mills, paper mills, textiles, machine tools, and these fans, pumps, robots and washing machines. So we will see one by one application. So this is one application of speed application. This is a speed application. In this speed application, if you observe, in the first, I am taking a 3-phase induction motor. This is a 3-phase AC induction motor. In this 3-phase AC induction motor, as it is mentioned 3-phase, so there are 3 phases given to the induction motor. So for this, he has given that the induction motor is a fixed speed. So if you observe, speed of induction motor is, it is running at 1300 rpm. So for example, it is running at 1300 rpm. This is a pump inlet flow. So induction motor will pump the water through a pump, and it is sent to the here if you take, it is sending water to the agriculture land. So it is of continuous process. To control this output flow of water, we have to control manually here. So this control valve is manually controlled. control. So instead of this, we are moving on to drives. So in these drives, we will use a variable frequency drive here. In this variable frequency drive, a 3-phase power is sent to the variable frequency drive. This variable frequency will adjust the speed. As induction motor, here he has given that variable speed, so we can adjust the speed of induction motor. So we can adjust the range also. For example, we can take it is rotating from 150 rpm to 1300 rpm. So we can take this range, so we can vary the speed of a induction motor, so that if we want to more outflow of a water, we can increase the speed of induction motor, or if you want the flow of water less, we can decrease the speed of induction motor. In this way, the flow of water can be controlled. Here the flow of water can be controlled, and here the speed of induction motor also controlled by using the drive. Here we are using a variable frequency drive. This is one application of electrical drive, and we will move on to second application. Here he has given a paper mill process drive application. If you take here, logs are there, logs. From these logs, it is crushed into pieces through a motors, crushed to pieces, and it is sent to the boilers, and it is given to a perfect shape through every process, and paper can be made out. So for this process, we require an electrical drive, because for this process voltage can be varied, speed can be varied, as well as current can be varied. These three quantities can be varied. So for this variable voltage, speed and current applications, we require an electrical drive. This is also one application for electrical drive. And we will move on to third application. This is a traction. As you know, traction is for electrical locomotive. So for this electric locomotive, this is modern AC electrical locomotive. In India, we will use maximum the DC traction. DC traction we will use in India. So if you observe AC traction, so for AC traction, the power can be sent through a power line. This is a power line. So this is a power line. From the power line, the power can be sent through a pantograph to this DC link. So from this, the inverter which will convert DC to AC, and this AC power can be sent through the AC motors. So as you know, AC motors will work through a AC, no? So we can convert DC to AC, and we will supply it through the motors. Here axle brush is there. Transformer is used for step up the voltage, and here another main rectifier is also there. It will convert AC to DC. So if you observe here, it will convert from AC to DC, and inverter will again convert from DC to AC, and it is sent to the blowers as well as these compressors we can use. Here for emergency supply we can use the battery. So for all these conversions from AC to DC and DC to AC conversions, we require an electrical drive. So for this traction application also, we will use an electrical drive. So we will move on to next applications. We can use in trains and tramways also. For modern applications, trams, for little buses and battery cars also, we will use these electrical drives. And pulley arrangements. This is a pulley arrangement. So one pulley is connected to 3 loads. This you can take an example of pulley, and it is connected to one motor, and these motor will supply the power to the load 1, load 2 and load 3. So for n number of loads we can connect through electrical drive applications. This also we can use for looming mills. In looming mills we can use this type of electrical drives applications. So in the SCADA and PLC, for conversions of SCADA and PLC, if you take an example here, I want to pump this water from tank. So from this pump I want to fill in the tank. First I will give a program through a SCADA, supervisory control for acquisition, development acquisition. For this SCADA application I am taking a measured flow level data. So how much water I should require, water, and this data it will take, and it is given a programmable logic to the circuit. So from this it will take to programmable logic data and pumps the control data. So how the pump will pump the data and it is sent to the tank. So here I can use the two number of PLCs also for valve controlling and for also flowing of the water. So here the flow of water as well as through the valve controlling process. Also we will use the electrical drive. So for all these domestical and industrial applications we will use the electrical drives. So we will move on to electrical drives. What is meant by electrical drives and the parts of electrical drive we will see here. The parts of electrical drive. So this is an electrical drive. So the definition is an electrical drive can be defined as electromechanical device which is used for converting electrical energy to the mechanical energy. So electrical drive is a device which will convert electrical energy to the mechanical energy. So which will convert electrical energy to mechanical energy to impart motion to the different machines and mechanisms. So for this process it requires a process control. You will see this process control. Here he has given a block diagram of an electrical drive. Here this is a block diagram of electrical drive. In this block diagram he has different parts. So first power source. This is a power source. For drive to work the drive, a power source is required. This power source can be AC or DC. The power source can be AC or DC. And the power converter, we will see the power converter. For power converter there are certain applications like this power converter. This will perform some of the following functions. So we will see one by one. First function, it will convert electrical energy from source to suitable motor. So if we want to convert for example AC to DC motor, we have to convert. So AC to DC conversion we require and it is sent to the DC motor. This is one conversion. Or I can also use DC to AC conversion. So DC to AC, again it is sent to the AC motor. So this application is first application to convert electrical energy from one source to another source to the form of suitable electrical motor. If you want to supply DC motor, AC value is rectified to DC and it is sent to the DC motor. If I want AC motor, DC to AC conversion will be there and from AC to AC motor will be run. So this is a first function. And second function, this is second function to control the flow of power to the motor. So to control the flow of motor power as well as torque speed characteristics. I want to match the two speeds. Torque speed can be controlled as well as power, flow of power flow can also be controlled. So second application is we have to control the flow of power as well as torque speed controls can be maintained. And third function is transient operations. So for motor we have to transient operations, such as we have to start the motor, as well as we have to maintain the braking, as speed reversals. These all can be maintained through a power converters. So for starting, braking and speed reversal conditions, we will use a power converter. This is also a one function. Next function is select the mode of operation. So mode of operation means we have to operate the motor can be operated in two ways. It should be started as a motor, or it will run as a motoring. We will say it as motoring. If we run as a motor, it will take as a motoring, or we can apply braking. So we have to stop the motor in the braking. So for these two mode of operations, we have to require a power converter. These are the functions of power converters. So we are require these conversions for the power converter. Next we will move on to, they have another function also. They provide adjustable voltage, current and frequency to control the speed. We have to control the voltage as well as current as well as frequency. These all should be matched or synchronized. These all should be synchronized with the speed of a motor. So these function also maintained through the power converters. So as you know, converters are classified into these types. First, AC to DC. For AC to DC, or we can call exactly as fixed AC, which will be converted into variable DC. Fixed AC can be converted into variable DC. So fixed AC power can be converted into variable DC power by using rectifier. And second conversion, choppers. In the choppers, fixed DC power can be converted into variable DC power. And in the third conversion, we will use AC to AC. So we can say that fixed AC can be converted variable AC. Fixed AC can be converted to variable AC at a constant frequency. Here we will use a constant frequency. So fixed AC to variable AC power with a constant frequency we will use in the voltage controller. And cycloconverter. So in the cycloconverter we will use the same way of voltage controller. Fixed AC power can be converted into variable AC, but here frequency can be controlled. So frequency can be varied. Here we will use variable frequency in case of cycloconverters. And in the inverters we will use DC to AC. So fixed DC to variable AC. So we will use these conversions, fixed DC to variable AC conversions for inverters. And the next classification is motors. In the block diagram, if you observe, we have seen power source. In the power source, AC or DC will be there, and power converters all I have said rectifiers, inverters, as well as choppers, and voltage controllers, as well as cycloconverters. We will use all these devices for the power conversions. And next classification is motor. So we will see the motors are classified into, as we take DC motors are shunt motor as well as series motor as well as compound motors. This is of DC motors. If you take AC motors are we can take induction motors as well as synchronous motors. AC motors are induction motors as well as synchronous motors, and we can take a special type of motors also. Special type motors like stepper motor as well as brushless DC motor. These are of special type of motors. So we can take these motors for applications. Next classification of this is load. So we can take the load as fans. We can take load as fans, pumps and washing machines. These are we can take as a load. For all these we have a sensing unit, no? So for conversions we require a sensing unit. So sensing unit will sense the output of a load, and it will give us the control unit. So from the control unit we can adjust the voltage, current or frequency or speed can be varied through a control unit, and it is sent to the power converters. So all these conversions will be taken place in the block diagram of electrical drive. So all these for power source we can take AC or DC, and power conversions will be takes place from these types, and we will require a suitable motor, and it is sent to the load. Load can be as well as fans, washing machines, pumps we will take, and their load can be varied through a sensing unit. We will sense through a devices like tachometer, and we will send the signal to the control unit. So in the control unit we will adjust the voltage, current as well as frequency, speed, and we will send to the power converter. This process will be continued in the electrical drive. Okay, thank you guys, we will meet in next class.